All right, so good day, everyone. Welcome to our class once again. This is your favorite teacher, so Peter, or Engineer Peter James. Hopefully, we can learn something today on differential equation. And what we're going to be doing today is more on differentiation. And this time, we would be learning exponential functions. It's like every single time we meet, we have something new to learn because there are different strategies and different approaches in doing differentiation. And math comes in different forms. So we have to be ready to solve math. As it comes in different forms, we must be ready to offer different solutions. Okay? But the goal is to perform the same thing. Differentiation, however, in a different way. Okay? Now, this time around, let's say, for example, I'm just going to dive in and not waste much of your time because I want you to understand the concepts. We only have a few minutes left. Correct? So let's say, for example, listen carefully. We have f of x is equals to y, right? So let's say, for example, we are given an assumption, and when we say something is an exponential in an exponential form, for example, we have y is equals to 2 to what? To the power of what? E to the power of x. That is an exponential form. It has a power. And if you remember correctly, when we're doing this, one question comes to mind. What comes to mind? If you remember, when you have an exponential form, do you remember our series expansion method when we did continuation?
Yes.
Continuity? You don't remember? When we had the series expansion form, whenever we have e to the power of x, we have a series expansion form in order to define a proximate value that is close to the exponential of what? Of x. Okay? We don't know what the actual value is because it has no end. Remember that. So in this case here, if we apply the series expansion method, if you remember, we said that whenever we have e to the power of x, it simply is what? 1 plus x squared over what? 2 factorial. Some of you have been asking me what factorial is. I'm going to define what factorial is once again so you remember.
Plus 1.
And then we have x to the power of 3 over 3 factorial plus x to the power of 4 over what? 4 factorial plus and so on and so forth. Now, when we say the word factorial, it simply means the product of its consecutive descending terms.
Oh, but I thought it was something.
Okay, the product of its what? Of its consecutive terms in a descending order. Do you get what I mean? In a descending order, meaning to say by 1, simply by the difference of what? 1. So when I say 5, the 5 factorial, it is 5, 4, 3, 2, 1. The product of 5 times 4 times 3 times 2 times 1 in a descending order. Okay? All right, so let's go ahead, let's continue. So in the case where we have y is equals to e to the exponential of what? E to x, we can replace it by having y is equals to 1 plus x plus, let's just make it short. I don't want to have too much. Plus x to the power of 3 over 3 factorial plus x to the power of 4 over 4 factorial and so on and so forth. So if we decide to work on this and find the derivative of this guy, what we're going to be doing in this case, let me make this smaller, is to have, instead of y now, we can have dy over dx, because now we can find it with respect to what? Dx, right? Am I correct? So this would be what? What would it be? What is the derivative of 1? We can use the general form. What derivative of 1 is 0, so no need to write it. What is the derivative of x? It becomes what? 1. Can you see that? Next, plus, what is the derivative of x squared?
2x.
It becomes what? 2x over 2 factorial. Keep it there first. What is the derivative of 3x? It becomes what? 3x squared over 3 factorial. I'm going to show you why it's not going to be changing. It's still going to be indefinite. Plus 4x cubed over 4 factorial plus and so on and so forth. Now, why is this guy problematic? Why is e to the x, the exponential of x, the exponent e to the power of x, indefinite. It is because if we decide to simplify this guy, for example, we can say um dy over dx is equals to 1 plus, I can say 2 over 2, because this is 2 times 1 x, correct? Plus 3x squared over 3 times what? 2 factorial. Is that the same?
Yes, sir.
Because 3 factorial is the same as what? 3 times what? 2 times 1. 2 factorial is equal to what? 2 times 1. So that means 2 factorial is what? This. This is 2 factorial. So I can have, if I have 3 factorial, I can say it is what? 3 times what? 2 factorial. Make sense? If I say 10 factorial, it is also the same as what? 10 times what? 9 factorial. Is that clear?
Yes, sir.
All right, so let's continue. So this is plus 4x cubed over 4. Let me write my cube correctly. Multiply by 3 factorial plus and so on and so forth. So 2 cancels 2. Bye-bye. 3 cancels 3. 4 cancels 4. So what is my answer now? My answer now is now what? So dy over dx now is equals to 1. We're going back to the original term now. It's like it keeps repeating itself. It's like, look, bro, you're not going to end with me. I am with you forever until the end of time. So we end up getting the same thing plus what? X plus x squared over what? 2 factorial plus x cubed over 3 factorial. If I continue, I'll continue to get the same thing. So plus and so on and so forth. Go back to the question. What did I say was what? Look at it here. What did I say was, look at it here. E to the power of x is equal to what? It's still the same thing. Makes sense now?
Yes, sir.
It's keep repeating. It's like, okay, you want to try me? Let's go back. I'm in infinity. I'm not going to stop. Let's go. Let's go. Let's go. That's exactly what it is. So that is what this do is. So this is equals to what? E to x to the power of what? X.
The derivative of e to the power of x is still e to the power of x.
It doesn't change. That's why it's repetitive. Are we clear, everyone?
Yes, sir.
Any question from my humble people far and near? Bea, any question from you? Oh, good. All right. I shared the link on the chat box. Okay, so please just follow the link for the whiteboard. Okay. Now let's add more questions. Let's get more questions. So let's say, for example, we have a simple question. Let's solve questions now. All right, implicit question. Let's say example number 1. I love this kind of question. So let's say we have a question like y is equals to e to the power of 4x. Would you like this one? It's a good question. E to the power of 4x. We can determine the actual value of these dudes now. Let's see what's going to change. Let's see what is happening to that e. He's a weird guy. He hardly changes. But let's see what happens to the e. Let's see the actual value if we decide to differentiate e to the power of 4x. Now, remember chain rule?
Yes, sir.
What do we do when we do chain rule? We say what? Let u be equals to what? 4x. Do you still remember?
Yes, sir.
And then we find what? du over dx. Beautiful. You still remember, which is equals to what is du over dx? In this case,
4.
it is what?
4.
It is 4. Right? So now let's find, so that means y is now equals to what? This y now. If du over dx is equals to 4x, so therefore y is equals to what? E to the power of what?
4.
U. Wait now. E to the power of u. Right? Because we said u is this. Am I confusing anyone?
Okay.
Am I confusing anyone? Yes. Okay. So let's continue. So if y is equals to e to the power of u, then what is dy over what? dy over what? Du. Because this is the only guy we don't know. This is the guy we're looking for. It's the input value now. It is the only input value in our variable, in our equation. Don't forget. It's there. E we don't know. E is a weird guy. U we're trying to find the value of u so we can determine the input. I mean, we're trying to determine the output based on what? The input variable. Am I confusing anyone? All right, let's go. You all say math is easy, so enjoy it. Can't believe I made math so easy. I don't like this feeling. So therefore, this is equals to what? What is it going to be?
40.
It's u.
UE, sorry,
Is it ue?
or just you.
Are you sure it's ue?
Or is it just you?
It is what it is. It's not going to change. Okay, so dy over du, it's still going to be what? E to the power of u. It's not going to change. Do you know what u is? U is not a number. It's a variable. So how can you subtract one? It is only when it is a constant that you can subtract one. If it's not a constant, let it be. Let it be. As long as you don't determine, you don't know the value, let it be. So what is the next thing? So let's go ahead. Let's continue. Pardon me. Just wipe this off. So let's continue. So therefore, we know, in other words, now we know, right? We know that we can find what? The derivative. So we can find what is the derivative, therefore?
DY over
It's dy. We're looking for dy over dx, which is equals to what? What are the two things we had? We found what?
DY over DU
We found dy over du times what? Du over dx. What did we get du over dx from? You still remember?
Yes,
Look at du over dx here.
4.
You still remember? So if we multiply them together, we cancel them out, we're going to end up getting dy over dx. That's the chain rule. So therefore, dy over dx is equals to EU multiplied by 4. So therefore, my final answer will be equals 4EU. Imagine the actual question was what? Y is equals to E4x. But now dy over dx is equals to what? 4E what? U. But we're not done yet. What is U?
4
It's what?
4x.
4x. So therefore, don't forget you're not done. But the fact I said is the answer, you're not done. You have to represent U because there's no U in our equation here. There's no U. So what is U? If U is equals to 4x, therefore dy over dx is equals to what?
4EU.
4e what?
4e to the power of 4x.
4e to the power of what? 4x. That is the answer. So if we have a function like this, what we have to do is take the 4 and keep it there. Let it be. Find the derivative that now I'm going to talk about something. Let's take another example, quick example. Maybe that will.
That's the final answer, right?
That's the final. This is the final answer. There's nothing else that you can do because the exponential of e is a naughty guy. It is very much undefined. If you have a variable, please do not tamper with it. You don't know what it is, let it be. Let him cook the way it is. It's just like telling me you put a rock in a boiling water and you expect it to soft. Do you know the value of the rock? You don't know, right? Question. One more example.
Yes, yes.
Okay. So let's take more. So question number 2, example number 2. Example number 2. Let's say for example, guys want to try this? Y is equals to e to the power of x to the power of what? 2. E to the power of x to the power of 2. Like Sir Peter, what kind of equations are you giving us? But it is real.
There's a 2x to the power of x squared.
Let's check it out. What did you say?
2x to the power of x squared.
Right. It's easy. All you have to do is what? Find the derivative of what? the power, right? And then multiply it by the term, and that's all. That's the shortcut way. That's the short way to doing it.
Uh, 2x e to the power of x squared.
I'll show you the shortcut. You know what?
X e to the power of x plus the derivative of x squared is 2x times e to the power of x squared. That's 2x e to the power of x squared.
That's a shortcut process. You figure it out easily because he realized I said it from the first question. That is why he remembered it. All right, so let's solve it. So again, using the same chain rule method, using chain rule. By the way, guys, you can check this on the YouTube channel. Okay, ask questions there if need be. All right. I have not uploaded the previous one, but I'm so sorry. So I want to be a YouTube star. Please. All right, you follow. You're not following me on YouTube, so make sure you all follow me on YouTube. Look for my name and follow me on YouTube. Let's build it up. Can you imagine my students are not following me? I'm watching all of you. I'm watching you. My eyes are there. So using chain rule, did you follow? So using chain rule, if y is equals to e to the power of x to the power of 2, I'm referring to every one of you. Jet, Denver, Vaughn, you better follow me on
Yes,
YouTube.
sir.
Every one of you. And every one of you watching,
Yes,
better
sir.
follow me. Otherwise I'll kick you out. Even those people, future people, kick you out of my channel. I don't see you following. Give comments, okay? Okay, so remember we said when we have a scenario like this, the first thing we're going to see, let u be equals to what? X to the power of what? 2. So what is du over dx? That is equals to what? What is it? What is du over dx?
2x.
Look at this guy here. It is x squared. So we just take this one and multiply. We have 2 times what? X is the power of 2 minus 1. So that is what? 2x. I'm always repeating the same thing all over and over and over and over again. So now we found this guy. So let's check this guy now. So what is, we have y. So therefore, y is equals to what? E to the power of what? U. And what is the y over the u? It's still the same as what? EU. Because we don't know what u is. We don't know what e is. So we best not play with water. Put stone in water. Keep it for 5 days. It's still going to be stone.
So this is related to the thing that needed, right? The e to the power of x. Just e to the power of u is the same thing.
Yeah.
Doesn't change.
Doesn't change. All right. So what's the next step? Our next step.
Multiply both derivatives.
Hold on.
Multiply both derivatives.
You're confused about something? You're just terrifying. Okay. All right. So next. So since we know again, so therefore dy over dx is equals to, because I must end up getting dy over dx. So I have d what? du over dx
Times dy over
multiplied by dy over du. So cancel, cancel. What did I do? Sorry, I canceled the wrong thing. How dare you, Denver, laugh at me? How
Ha!
Oh, shut up, Denver.
don't laugh at me, right? I'm watching. My eyes are there. So therefore, we have our dy over dx is now equal to, so what is du over dx? That is eu multiplied by 2x. So that is going to be what? 2x eu. And we know that u is equals to what? X squared. So all we have to do is just substitute at the end of the day. So our final answer for dy over dx is equals to 2xe to the power of what? x squared. Can you imagine how complex complex it started to go? Right? It's a weird question, but at the same time, it's nice. So the shortcut, when you have this simple question like this, I shared the link out. You can go check it there. The shortcut, when you have something like this, checkmate. All you have to do is what? If you have y is equals to e x to the power of what square, all you have to do is what? Find the derivative of this guy, then multiply by the dude here. What's the derivative of this one? It's what? The derivative of that guy is what? 2x. So if I multiply 2x by this guy, I'll end up getting the same answer. So the y over the x is equal to what? 2x squared. Same. Question number one. Go to the first question. Again, let's check it out and see if it works. Here it is. This is the question. Y is equals to what? 4e to the power of what? 4x. What's the derivative of 4x? 4. So if the derivative of 4x is equals to 4, so therefore dy over dx shortcut is equals to 4e to the power of what? 4x. Yeah, it's still the same thing, same answer. All the explanation I did still ended up the same thing. So I'm teaching you shortcut and long cut. Anyone you understand, go ahead and do it. Life is not hard. Life is easy. Okay? So let's take some serious examples this time around. Let's see if this might make sense to every one of you. So maybe you can try the shortcut method. I don't know what you want to do, but I want to make it a bit more complex. Huh?
No need, sir. I'm gonna make that exponent.
Why is equal to no? I'm gonna make it a bit so e is the power of 4. Let's make this a bit complex. 4x cubed minus 9. So go ahead and solve this polynomial equation. So what do? You can use the shortcut to solve this as fast as possible.
12x squared e to the power of 4x minus 9. Oh, this means 12x. 12x squared. So that's a 3, right? 4x.
Yeah, it's a 3.
That's 12x. Right. E to the power of 4x cubed.
Wow, I'm so proud of you. It's like you don't need a pen to solve this question now. I'm so proud of you. All right, so again, still the same thing. Easy peasy. Easy peasy. Now you know what to do. Shortcut. You do this, right? Find the derivative of that guy, and the derivative of this guy is what? 12x squared. You see that? So automatically, what do we have? So we just multiply 12x squared. So we have dy over dx is equal to what? 12x squared e to the power of what? 4x 3 minus what? 9. That's it. Life's not hard. That's easy. Don't make it complex. I taught you the hard way. I showed you the easy way. Now you're doing the easy way. How dare you?
So that's how life is.
How dare you? Really? You want to class this miss already? So I have maybe just 2 questions that I can just drop here. So in case you're online and you want to try it out, you can try. In case you want to do it on your own, it's fine. Okay? Remember, it's all in your mind, right? That's what my dad used to say. Math is all in your mind. The complexity of the math is all in your mind. There's always a way to solve it. So these are the 2 questions. Question number 1, we have y is equals to, I want you to use the long method, the changeable method, and solve it. E to the power of 4x cubed plus 2. And the second question is y is equals to e raised to the power of 3x squared plus 6x minus 7. Close the parentheses. So I want you to play with these 2 problems.
I'm gonna be honest.
Yeah.
The long method and the short method are literally the same.
They are.
It's not different. It's just that you make the exponent like you. That's it.
It's chain rule. Still remember how to solve your chain rule, right?
Yes, sir.
Okay. When do we use chain rule?
There's exponent.
When there's an exponent? Really?
Sure. It's not how.
You have forgotten.
There's no when and how.
So try it out. Um,
So is it when there's a polynomial?
yeah, when it is a polynomial. That's when we use chain rule. Multiplied by itself. All right. So please play with these two questions. I'll let you play with them on your own. If you can do it correctly, the first answer should most likely be when you have dy over dx. If you solve this correctly, you should end up getting 12x square e to the power of 4x cubed plus 2. The second one, you should get dy over dx should be equals to, what would you get here? Let's see if you can figure it out. She gets 6x plus 6, correct? And then it's not an e, everything is multiplied, a multiplier of e to the power of 3x squared plus 6x minus 7. You should get this.
That's the final answer, sir. Or we get.
Or you can still simplify. You can have this dy over dx. It can be simplified. You can have 6, open the parenthesis, x plus 1, close. You have your e, raise the parenthesis, 3x squared plus 6x minus 7.
We can also distribute the e, right?
There's no need to distribute the e.
But
You're going to make it very complex.
Yeah, but e can if you want.
You want to waste paper?
No,
Save paper, save the earth.
That's right. I don't want to. I'm just saying.
Yeah, save paper, save tree. If you were a tree, would you want to be used as paper? Wasted? Come on, dude. Leave. Let's leave.
So why do we need paper when we have computers?
This is radiating. This produces generates more heat,
Well, the ball.
and it makes us less sustainable. Everything has its downside. If there are too many electronics, we're producing too much radiation, and it is killing our atmosphere, making the earth hotter.
Other than the Philippines.
Oh, it is. Let's leave any country out of this, okay? All right, so thank you. That will be all for our class. Do you guys have any questions? I want to end the class. Any questions so far?
None, sir. None, none, none.
All right, so that will be all. Thank you so much to all my viewers, wherever you are in the world. Enjoy, and hopefully we get to post this one, and then I'll see you in the next video, which will be on the logarithmic differentiation. Goodbye, au revoir, bon voyage, bye bye.
Bye,
Yeah,
Sir
don't
Pogi.
forget to like and subscribe. Thank you so much. Everyone, see ya.